Math 3 Mixture View. Use the information on the unit circle to graph f of x equals negative 2 sine x over the interval 0 to 2 pi, then identify the list of characteristics for the function. Hint: what type of transformations happen because of the negative sign and the 2? So, a negative sign in the front of a function like that is a reflection over the x-axis. So everything is going to be flipped upside down. The 2 is your vertical stretch, or when you're talking about sine and cosine graphs, that's the amplitude. So instead of everything being 1 tall, everything's 2 tall. So vertical stretch. So once you've done a lot of these, hopefully you've been noticing that sine graphs are always starting at the origin, and then cosine graphs are always starting off of the origin. If you don't know that, then you can just go through and look at your unit circle to get all of the points that would be on the normal graph of sine x, and then we can just use our transformations to modify or transform everything. So let's go ahead and do x and sine x off of the unit circle. And I'm going to use these critical values right here as my points for my x values. So I'll do 0, pi over 2, pi, 3 pi over 2, and 2 pi. So those are the values I'm going to use off of the unit circle. So, and we're talking sine. So we're going to be looking at the y values on the unit circle. So when we're at 0, our y value is 0. I'm going to jot these down on a piece of paper so we don't have to keep scrolling back and forth a million times. So again, when we're at 0, the sine is 0. When we're at pi over 2, the sine is the y value, so it's 1. When we're at pi, the y value is 0. When we're at 3 pi over 2, the y value is negative 1. And then when we're at 2 pi, the y value is 0 again. So again, I just jotted those down on a piece of paper so I wouldn't scroll back and forth like I've done in all the other videos. So we had 0, 1, 0, negative 1, and 0. So these are where the graph normally is. And what I'm going to do is I'm going to go ahead and graph sine x on this grid in red, and then we can do the other graph in a different color to see how it changes. So 0, 0, pi over 2, comma 1, pi, comma 0, 3 pi over 2, comma negative 1, and then 2 pi, comma 0. So this one in red that I'm doing, this is your normal sine curve. So that's sine x. So y equals sine x. That's the red curve. Now, if we want to do the actual graph that they want us to do, let's do that in blue. So the negative sign we already talked about makes us reflect over the x-axis, and then the 2 makes everything multiplied by 2, basically. So if I look at this first point, 0, 0, when I multiply everything by 2, it just stays there, because 0 times 2 is 2. And then as far as flipping over the x-axis, it's already on the x-axis, so it just stays there. Next point over, I take the value of 1, because that's the y-coordinate, 1. So I'm looking at this point right here. I'm going to multiply that basically by negative 2. So 1 times negative 2 is negative 2. So I'm going to be down here instead of up at positive 1. I'm going to be down at negative 2. Next point, pi, comma 0 is just going to stay put because 0 times negative 2 is 0. Next point right here is 3 pi over 2, comma negative 1. So I am going to multiply negative 1 times negative 2 to get positive 2. So I'm basically flipping over the x-axis, and now it's getting taller because of the vertical stretch. And then that last one, 2 pi, comma 0, should just stay put. So this blue graph that I'm drawing is our new graph. Notice it's a sine curve, but it's upside down, and it's taller. The amplitude has gotten bigger. So the period is still 2 pi, I'm doing the large x value minus the small x value. And every sine and cosine graph, if it's just a normal one and it hasn't had a period change, the normal period is 2 pi for sine graphs and cosine graphs. Our minimum value is -2 because that is the smallest y value on the graph. So I'm just going back here and labeling my blue graph. And then my maximum value is 2 because that's the highest y value on the graph. And then if you want to actually calculate the amplitude with the equation, it's 1/2 the absolute value of the max minus the min. But we already know that it's going to be 2 because the amplitude is always that number right there. It's whatever the vertical stretch is, that's the amplitude. But if you want to see the equation, it would be max minus min. So then you'd have 1/2 times 4, which would be 2. And then my midline is y equals the max plus the min divided by 2. So 2 plus -2 divided by 2 should still be 0. Because we didn't have any vertical translations or anything. So y equals 0. And again, to tie everything together, so y equals 0, this purple horizontal line I'm drawing here on the x-axis, y equals 0, that's my midline. So the distance from the midline up to the max is 2, and the distance from the midline down to the minimum is also 2. And that should be my amplitude, which, sure enough, it is. Number 2, use the information on the unit circle to find the exact values of the trigonometry expressions below. So remember, sine is the y value, and cosine is the x value. So cosine is the x, and sine is the y. So for this first one, part A, we want the y value at 45 degrees. So 45 degrees is right here. We want the y value. So √2/2. For the next one, we want the x value at 11 pi over 6. So we have to find 11 pi over 6. And then we want the x value. So √3/2. √3/2. And then on this last one, since it's sine, we want the y value at 180 degrees. So y value at 180 degrees. Here's 180 degrees, y value is 0. Number 3, convert the following radian measures to degree measures. So anytime you're trying to convert from radians into degrees, you want to multiply by 180 degrees over pi radians. The rule of thumb is that whatever unit of measurement you want your answer to be in, those are the units you want in the top of the fraction. So I would just multiply across the top. So 8 times 180 is 1,440, and then bring the pi with you. And then across the bottom, 5 pi. So the pi's cancel out, and then 1,440 divided by 5 is 288 degrees. For part B, same thing. We have radians. We're going into degrees, so we want to multiply by 180 degrees over pi radians. So multiply across, 5 times 180 is 900, and there was a pi up top, so bring the pi with you. And then 6 times pi in the bottom. We're going to cancel out the pi's. 900 divided by 6 is 150 degrees. Number 4, convert the following degree measures to radian measures. So if you want to go into radians, you want to multiply by pi radians over 180 degrees. Because again, whatever unit of measurement you want your answer to be in, those are the units that need to be in the top of the fraction. I usually like to put the 340 over 1, and then I just multiply across the top, multiply across the bottom, and then calculators can do this reduction of the fraction for us. So before spring break, I had you download the Calculate 84 app. You should just hit math and then frac is the first option, and then enter, and it reduces the fraction for you. So that reduced down to 17/9 pi. Don't forget the pi. Sometimes people forget that. Speaking of pi, when I reduce that in the calculator, I do not type in the pi symbol. I just do the 340 divided by 180. I do not type in the pi symbol. Part B, I want to multiply 50 degrees times pi over 180. So going across the top, I have 50 pi. Multiplying across the bottom, I have 180. So when I reduce that, I get 5 pi over 18 radians. Number 5, analyze the two functions below. Determine which function has a greater, steeper average rate of change over the interval -2 to 0. Circle the function that has the greater value and show work to justify your answer. So average rate of change is basically slope. When we look at the first function, f of x, we want to determine 2 points that we can use in the slope formula. Keep in mind this interval -2 to 0, those are both x values. So we're going to basically take f of -2 and figure out what the y value is when the x value is -2. So it looks like it's going to be 10. Then we want to figure out what the y value is going to be when the x value is 0, since that's the other x coordinate in the interval they gave us. So wherever I see an x, I'm plugging in a 0 in parentheses. So that looks like that ends up being 4. So what happens is we have 2 points. We have -2, 10 as 1 point. So this is x sub 1 and y sub 1. And then we have a second point at 0, 4. So this is x sub 2 and y sub 2. Then we just do our slope formula, which is change in y over change in x. So y sub 2 is 4 minus y sub 1 is 10 over x sub 2 is 0 minus x sub 1 is -2. So be careful with that double negative in the denominator. Up top, 4 minus 10 is -6. In the denominator, that double negative turns into a positive, so we get 2. And then -6 divided by 2 is -3. So the average rate of change from -2 to 0 for f of x is going to be -3. Now let's try the graph. So when x is -2, y is 0. So that's 1 point we're going to use in our slope formula. And then when x is 0, our y value is -4. So that's the other point we're going to use in our slope formula. So this could be x sub 1 and y sub 1. This could be x sub 2 and y sub 2. And then we'll just plug it into the formula for average rate of change, which is your slope formula. So change in y over change in x. So y sub 2 is -4 minus y sub 1 is 0. And then x sub 2 is 0 minus x sub 1 is -2. So -4 over 2 equals -2. So they want to know which one has the greater average rate of change, and I even put in steeper in parentheses so there was no confusion. So the steeper slope is going to be the number that is, basically it has the greater absolute value. So -3 is going to have a steeper slope than -2. So it says we want to circle the function with the greater value, so it would be this one. That f of x would have the greater slope from -2 to 0. Number 6, Laura can complete 8 projects in 3 hours. So Laura can do 8 projects in 3 hours. If Laura and John work together, they can complete 10 projects, so total 10 projects in 4 hours. So that 4 hours is the time it takes them to get 10 projects done working together. working alone, how long would it take John to complete 5 projects? So here's John, 5 projects divided by his unknown amount of time. And then let me put this 4 closer to where it goes, like that. So there's your initial setup. Now, as far as the solving goes, our least common denominator is 3x, because those are the values in the denominator. So we want to multiply all of the terms by 3x in order to get rid of all the fractions. So 3 and 3 cancel out in that first fraction, and we're left with 8 times 4 times x. In the second fraction, x and x cancel out, so we're left with 5 times 4 times 3. And then in the back, 10 times 3x is 30x. Now that all the fractions are gone, we just solve like normal. So 32x plus 60 equals 30x minus 32 minus 32. Ooh, I think we're going to get a negative answer, which means I did not make this problem well. So 30 minus 32 is negative 2x, divided by negative 2, divided by negative 2, x equals negative 30. All right, so I did not make this problem well. I guess for now, just leave this. If I actually made this problem well, you wouldn't get a negative answer because we're not going to talk about a negative amount of time. So what I'll probably do is I'll probably go back and change this problem, but I think I might be lazy and not re-record the video. So you know how to set up the problem, and then you can just look at the answer key that I will post. And we would have put hours on here, and maybe I'll just put a little note so you remember later. Check answer key. Check answer key for fixed problem. Sorry about that. Looking at 7, hopefully I didn't mess up any other problems. Looking at 7, we're going to solve each equation using any method. So when we have a radical, we have to isolate the radical on one side of the equal sign first. So the square root's already all by itself. So to undo something squared, I said that backwards. To undo a square root, you have to square it. And whatever you do to one side of the equation, you have to do to both sides of the equation. So x squared equals 11x minus 30. And then we want to get everything on one side and set it equal to 0, since there are x squared terms and x terms. So we have x squared minus 11x plus 30 equals 0. So we have a basic trinomial. So we're looking for two numbers that multiply to 30, and then those same two numbers need to add up to negative 11. So negative 5 times negative 6 is positive 30, and negative 5 plus negative 6 is negative 11. Set each factor equal to 0 and solve for x. So we're getting 5 and 6. Whenever you have a radical equation, you really should check your answers because you might have an extraneous solution that you'll have to throw out. So I'm going to check 5 first. So wherever I see an x, I'm going to plug in a 5 instead in parentheses. So 5 equals 55 minus 30. 5 equals square root of 25. 5 equals 5. So yes, that first one works. Let me try 6. 6 equals the square root of 11 times 6 minus 30. So 6 equals square root of 66 minus 30. 6 equals square root of 36. And 6 equals 6. So yep, they both work. We do not have to throw out either of the answers. So that's convenient. Part B. Looks like everything is on one side equal to 0. And it looks like a problem where they partially factored it, but they didn't completely factor it. So what happens is that first set of parentheses, you can't factor it any further. But when you look at your second set of parentheses, there's no greatest common factor. It's a binomial, so two terms, being subtracted. So that's that difference of two perfect squares type of factoring. And we know that because x squared is a perfect square, and so is 25. So when you have difference of two perfect squares factoring, you do the square root of the first term, and that goes in the first slot of the two sets of parentheses. And then you do the square root of the second term. That goes in the second slot of the two sets of parentheses. And then make one positive, make one negative. Now that it's factored completely, we just set each factor equal to 0 and solve for x. So 2x equals 3, since I'm adding 3 to both sides. And then divide by 2, divide by 2. So 3 halves is one of our answers. And then subtract 5, add 5, add 5. And we're getting x equals -5 and x equals +5. So you have all three of those answers. And then this last question, this is the newest thing you've learned. We want to solve each of the equations below for all radian measures over the domain 0 is less than or equal to theta, which is less than or equal to 2 pi. So the goal with these problems is to isolate the trig function and the theta. So on part A, we want to isolate this. So I'm going to add 1 to both sides of the equation to get sine squared theta equals 1. And then in order to undo something that's squared, you have to square root both sides. Anytime you introduce a square root into a problem, you're supposed to add a plus minus symbol. So sine theta is going to be equal to plus or minus 1. This is the part where we now look at the unit circle. Sine is the y value. So I want to look at y values of 1 and -1. Y values of 1 and -1. So I'm seeing that happen here. So pi over 2 is one of our answers. And I'm seeing that happen here. So 3 pi over 2 is one of our answers. So pi over 2 and 3 pi over 2. Theta equals pi over 2 and 3 pi over 2. And then this last one, we want to isolate the cosine theta by doing order of operations backwards. So subtract square root of 3 from both sides of the equation to start. And then to undo multiplication, you're doing division to get rid of that 2 in the front. So cosine theta equals -√3 over 2. So cosine, those are x values. So off of the unit circle, we're looking for -√3 over 2 for an x value. So -√3 over 2 for an x value. So right here, so 5 pi over 6 is one of our answers. And right here, 7 pi over 6 is one of our answers. And that should be it. So 5 and 7, 5 and 7. So 5 pi over 6 and 7 pi over 6. And we know to use radian measurements because it says so in the directions. And then that's it.